did yesterday?
I remember we did like power. Well, no, I don't know. We were doing like square roots and like squaring and how they can cancel out and how you can find square roots things and perfect squares.
Okay. Who remembers conceptually what we're doing, or like why we use squares and roots and things like that? What would we be finding when we find the square of a number?
That number multiplied by itself.
Right, but why would we do that?
I don't know.
Like a volume?
Not volume.
To find the corner length of a square.
Ooh, you're doing roots.
Oh, roots. Okay.
Monica?
To find a square with an edge length of that number.
Find the what of the square?
The area.
Yeah. So on your paper, if you don't have this drawn somewhere, even if it's up at the top, like in the name area or whatever, I want you to show that we use squaring. Draw a little square with like an edge length 3. The value, quote unquote, value of that square is 9 because that's the area, and we get that from 3 squared. Likewise, and you could draw this square a little bit bigger if you can, if we have a square of value 16, so bigger square, bigger value, right? Bigger square, bigger value. Its area is 16, and we're saying, what's the edge length? Andrew? 4. So the purpose of squaring is to find area. The purpose of rooting, square rooting, or we'll get to cube rooting and everything, is to solve the edge length. Okay, so the point of squaring and rooting is area or edge length. I just had to, the conceptual, I've realized in the past I haven't taught it well enough. The idea of it. So you're good.
Okay, so we went through different.
We went through 1A.
Okay, so the rest are kind of the same. So most of the time you'll just put each under the radical to do the opposite inverse, and you'll get the what the square root of it is. So with B, you'll get the same. You'll get a different answer than this one because the different values. But since it's 81, the perfect square of that is 9. So x would be 9. So why don't you try C and D, and then we'll go over them.
So when you're taking the roots, essentially in these examples, you're finding the edge length of the square. That is essentially what you're doing. Questions are for you, they're not for me.
Oh.
Can't you just like use can't you just do 9 times 9 to find out 81?
You could, but this.
But you don't know that 9 even exists if you just had x squared equals 81.
But if you're squaring it, it's that number multiplied by itself. 9 times 9 is like one of the only numbers I can think of.
It works like that with the perfect squares, but when you get into harder numbers that aren't perfect squares, it's a lot more complicated because, like, where I'm at in math, you have to, like, take a number that's not a perfect square and you have to find perfect squares that go into it, and then you have to find out what's left under the radical.
So don't get him too far off on that tangent because his math learning is up here and where he's talking is up here, and you're down here, so he's just talking over top of you kind of right now. But all you need to know is it's easy for you right now. It will get harder, and I'm not saying right now is easy, but this is the easy side of squares and square roots, where they're perfect. And that's why we call them perfect, because they come out to be integer values. So don't go too deep. They'll suck you deep in like the realm of where it goes. Try to stick where we're at.
Okay, so C. D.
X equals 4.
should probably capture it before I do anything.
Yeah, he's got it.
Any questions before I do it?
Aaron's got math skills.
Nice.
Now this is a big number. Push yourself. Now the trick is it ends in a 5 though. So big numbers that end in 5s, we know something about them. What? No, I'm making them recognize how we can narrow down our choices.
Yeah.
So like, I'm not going to use a number that ends in a. Well, never mind. I'm not going to start canceling out ideas for you.
25.
Yeah.
Oh,
I was way off.
yeah, it's easy.
So, an easy way to do it is you can go through your calculator and just do like, or 15 times 15, but that'll take you a while to get to it, because that's just like a guess and check method. But if you wanted to just get the square root right away on your calculator, you go second, I don't know.
And then it's
On top of the X2.
yeah, it's a
Yeah, over x2, you go second x2, and then you type in your number, it'll give you what it is.
Aaron, use
Also,
the big calculator. Use the big
Oh,
calculator.
give a poster.
Under the start.
Well, I didn't
So,
see that.
If you want to show them that, I normally grab a yardstick and like point.
What?
We haven't done too much deep calculator work today, so always make sure that you're looking at the second functions of the calculator. Often, if they're related, they will be secondary functions of the other button. So, like powers and roots. They're related, they're inverses.
Yeah, I did it.
Or their buttons are close. They've designed a calculator fairly well.
Okay. So, with fractions, it's kind of the same thing. You just put them both under the radical to find out what the answer is. So each of them get their own. So since you have 64 and 81, they both become a perfect square. So you get A equals 8 over 9.
Oh, so you find the square root of both the numbers and keep it as a fraction?
Yes. So that's when it's a fraction and they're both under the radical. They just stay as a fraction, and you take them both to the radical, or
Separately.
yeah.
So what's interesting about how this stuff works is essentially that a squared equals 64 over 81. When we go to square root it, there's a step between where it square roots the whole thing, and then it square roots the numerator separately from the denominator, because the division splits it. So right after this step, radical 64 over 81, there's actually another step where it's radical 64 over radical 81. That might be where you're having trouble seeing it.
So that's why you can do it like separately.
Yeah,
and
they
then
are separate actions. Because it would be totally different if you type in your calculator square root of 8/9, because then you're square rooting a value less than 1. And that's awkward to do, and we can't do that in our head, because that's like impossible. But if I square root the 8 and square root the 9, I get that, square root the 64 and square root the 81, I get the 8.
In a calculator, what if you put the square root of in
Do it.
parentheses 64 divided
Do it.
by 8?
Try it.
But then you get the
Try it.
decimal value.
Try it.
I already did.
But like the way
So, your calculator also, hold on, this is a calculator thing that they may or may not know about. Your calculator has 2 different modes. Depending on what mode you're in, depends on what you're going to get. So if you're holding a calculator right now, hit the button that says mode. If you don't know where it is, it's right there.
Did you radical, right?
If you want your answers to spit out in radicals, would put it into rad. But if you don't want your answers to spit out as radicals because we're solving this, keep it in degree, and then you probably want it either in classic down at the bottom or in math print. So depending on how you're getting your answers, if it's not giving you the form that you want, check those modes. You might need to switch from classic to math print or vice versa. You might need to switch between degrees or radical, or it depends on who had your calculator last. So everybody, you should be holding a calculator, but I know not everyone is. If you type in radical 16, you should get 4. If you don't, you need to change your settings. So if you can't figure that out, raise your hand, I'll come help you.
But for this, you can also think of it as like it's like 64 is being divided by 81, so you got to do them separately because they're both being taken to the square root by a. Okay.
And that's just how we do it, so we can do it without a calculator. You get the same answer if you type it into the calculator and do the parentheses, like the 0.8 repeating, honestly. Because 8/9 we know is 0.8 repeating. So we get the same thing, but we don't want 0.8 repeating. We want 8/9. We'd rather have the fraction answer.
In a calculator, is there any way to like input a number which goes on forever?
I
Like, is
don't
there a
believe so.
button for,
Well,
like, it
yeah,
goes on forever?
make it a fraction. Because we know how to convert any repeating value into a fraction. So yes, you input it as a fraction. Sorry. Move on. I'm doing way too much.
So go ahead and try to got it really quick.
So if you punch it in your calculator, you're going to get a decimal answer. That's not what we want. So don't put it in your calculator.
Well, you don't convert it.
Well, you could also do them separately in your calculator, but you'll save time just doing it in your head.
Any questions before we go to the next part?
Yeah. Wait.
In the calculator, every time I punch it in, it like gives me the fraction that it would be.
So your actually, let me
You
check
push,
your
you
mode.
push second, and then you push the.
Yeah, the
square.
FD.
Yeah, you push this, and then this, and then you just push the number.
Your calculators must just be happy with you. So depending on how they're set up.
Yeah, if you push this, and then.
Yeah, and then do. Sorry, you can move on, Aaron.
Clear.
Okay.
That,
So 64.
and then push enter.
Is y just another like variable?
Yeah, so
Oh.
That's what I'm talking.
you can use like any letter as a variable except for E. E is a weird thing I'm not gonna go into. We'll get into that math for you. But you can use any letter as a variable.
E.
Yeah, that's what I was.
Okay, so for this one, a company makes custom designs for stamps, and they have a square image area. So the image has an area of 122 or 1,200.
The image is there.
Mm-hmm. Yeah. And they want to know what the exact length of one side of the image area is. So if it's not a perfect square, you're gonna have to approximate what the area is. So you do it the same way as what you did up top. You just put it under the radical, and you round what comes out afterwards.
So they are talking about the area of the stamp. Forget about those little semicircles taken out. Don't worry about those. They're talking about the area of the square is 1,200.
So for this one, you get 34 and
0.64.
Yeah, 0.64.
so you get 34. And you round to the nearest tenth, so you get 34.6.
Why do you round? Do you have to round?
It's because it's asking in this question to round
Oh,
to the nearest tenth. So you'd have to round it. And then your units.
That's is it new? Oh,
Sorry.
I didn't use those.
And then you go ahead and try to got it. It'll be the same.
What? Yeah, I got something weird.
Okay, I did too, but then and then press that. There you go.
The enter?
No, press the button above enter.
Oh, that thingy?
And then it'll.
So, and this is what's dangerous. I don't like relying on that button too much. The button above the equals, the two arrows, that you might recognize from more basic calculators that would have the F on one side and the D on the other. That is your auto-convert fraction to decimal, decimal to fraction. So, yes, if you get a decimal value, you can switch it to a fraction pretty easily. But we would rather you think about these in your head, like if you're square rooting a fraction, I'd rather you square root each of the numbers individually and get the fraction answer by using your noggin as opposed to using your calculator and spending that time converting things and whatever else. So yes, it's an option, but try to work that mental tenacity to learn those square roots because it will benefit you to memorize as many of these square roots as you can. I'd advise up to 15, like up to 15 squared and square root of 225 because that's what 15 comes out to be. I'd memorize that set and you're pretty good.
Answer.
Oh, okay. Continue.
21.4 centimeters.
Any questions on how to do that one?
Would you like this, sir?
Oh, he's a son.
Square.
I use sir for a lot of my friends. It's just a sign of respect. Flip to zeta.
Oh, you guys are wearing very
Did you not? Did you not know when it started so long? Yeah.
This is what happens
Oh,
when you're class
Jeremiah,
leads.
Jeremiah.
Alright, be nice.
So next we're going to be doing perfect cubes and the cube root of numbers. So it's basically the same thing as doing just a square root, but the only real difference is you're dealing with a cube. So this one's 64 inches, like cubed, and that's its volume. You just do the same. So 64, and you want the cube root, and x equals 3. So it's you just put a little 3 there, and it's the same thing as a square root. And your answer would be 4, because you're doing it. It's like multiplying a number 3 times. So instead of just 2 x's in here, you have 3. So it's like x times x times x equals 64. So it's just like adding one more x from the last set of problems.
So we're literally talking about cubes. Like physical, tangible, imagine filling things with cubes. So in that, we could fit 64 little cubes that measure inch by inch by inch. So we're literally discussing what the words mean. We're talking about cubes. How many cubes fit inside of it?
Okay, so cube rooting gets a little weird where on square roots it could be positive and negative, and you guys won't have to deal with the negatives. But this one you will have to deal with negatives because doing the cube root a negative, if you cube root a negative or you take the cube of a negative, you can get a negative answer. So if you're trying to get negative 27 and you're trying to figure out what that is, it's just negative 3. So
Because a negative times a negative times a negative is a negative.
yes, it's
Yeah, exactly what she said.
think about it like this: exponents is just a number times itself a lot of times. So you can just think of it as negative 3 times negative 3 times negative 3. It's just an easy way to do it, so you don't have to write as much.
So let's talk again about why. Why do we multiply? Why would I say 5 times 4?
To get maybe area.
No, but like not what I use it for, but why did we invent multiplication? What about 5 times 87?
Oh, so we didn't have to
So
add it.
Whitney?
So you didn't have to add it over and over and over.
So we didn't have to repeatedly add 5 plus 5 plus 5 plus 5 plus 5 plus 5 87 times. So powers are the shortcut to multiplying over and over and over and over and over and over and over. So the power tells you how many times we're multiplying, like how many values we multiply together. So the power of 3 is multiplying 3 numbers together, and all the numbers have to be the same. So that's the why. It's shortcuts. Mathematicians like to be efficient, not lazy, efficient. So we create efficiency models. Go ahead. I just have to talk about why we use it. Now, the negatives, don't think about it. Like, it doesn't make sense to think about a negative something that was cubed. So don't think too hard. Just realize that if it was a negative, the cube root is a negative. If it starts negative, the cube is a negative.
What do you call it once there are like four, like the exponents of 4 or 5?
You just call it to the 4th power, the 5th power, the 6th power.
So you only call it square and cube for 2 and 3.
Because those are the only physical ones that we use. We only use squares because of area, and we use cubes because of volume. Beyond that, there's no real application tangibly.
Yeah, because like when you get in higher math, like you'll want to like memorize a couple of these, but like when you get into like 2 to the 4th, you'll like want to remember that, but no one's gonna care about 9 to the 4th.
Yeah, those get really big really fast. Question?
What's the point of having the negative when you can't have a negative?
You'll get there. You don't think too hard about it now. We just want you to understand how this works right now. Don't worry about the why for the negatives. I hate when people say that, but for where you're at right now, don't worry too much about the why for the negatives. You'll get there in a year or 2. Then you start talking about imaginary numbers.
What?
What's an imaginary number?
It's just adding
It's
a letter
named
I.
wrong.
You keep going this way.
It's
we're
not
gonna
actually
keep asking,
wrong.
what's this math? What's this math?
Imaginary number is kind of like this stuff, but all you do is add the letter I.
What's the point of that?
So,
That's all
if you
I'm gonna
want to
get.
talk about imaginary numbers, come talk to me at some point later. I have a whole packet, and I can show you a video series, but we got to move on.
If you really want to know, I probably have some of my math stuff.
Yeah, because Math 2 and Math 3 go way into that. I should show you that packet too, because you probably didn't work on it. I'll give it to you later while we're in the test.
So, for X, for this one, you do the same thing as the last one, and you get X equals 4.
And you can always check it.
Yeah.
Like I just heard Jeremiah say, wait, 4 times 4 times. Yeah. Like, check it.
Okay,
Answer for the D.
okay.
That wasn't a question.
No, it was an answer. X equals negative 5.
So a strategy that I sometimes use is when I look at a kid, I say question or answer.
Okay.
Like, because sometimes I want to talk beforehand, but mom still loves to give me
I have no
You
idea.
can never tell. You either as a question or an answer.
I know, and you can't tell by her body language.
You gotta be like, come on.
You gotta stand
You can always tell by Hudson. He's always got a comment. He just says it.
Don't raise your hand if it's me.
Okay, let's move on to the got it.
Wait, now you got a question.
No.
I have a question. I have an actual question.
Okay, give me a second.
Good question. And this actually has a question.
How do you keep on calculating?
So,
Oh, I can show you.
I probably should use mine so I help.
No, you don't press this. This kid is pressing T. You don't have to press second.
All right.
So for this one, you can do it 2 ways. You can do it with this one where you go 3, and then second, and that, and we'll 3 and 4. And if you do 8, you'll get 2. Second, and then a little turkey.
Jumping in once this loads. So it's going to pop up once it decides it wants to load.
You got it?
Peeps, grab a calculator. If you don't have one, grab a calculator. Okay, good. You're all rock stars.
Can someone give me the got it for this one? Never mind.
You're okay. Do that one. Actually, so, here on your calculator.
We're gonna wait on the answer for that one.
So you want to do the cube root of negative 64. This is a really good one to cover together on the calculator. So to get cube root, you're going to use, and actually this is the any root button. So notice that X, give me your eyes for a second, then do it. The X before the root is saying, what root do you want to do? So before you hit anything, you got to tell it what root. So I hit 3 for where I'm gonna do the third root. Then I hit second and that button. Notice it shrinks the 3 like what Aaron's been writing on the notes and what hopefully you've been writing on the notes. That's now saying cube root of whatever you type in. Now you must make sure that you're using, quit falling, the negative button, not the minus. Otherwise you'll get an error. So we type negative, what was it, 64?
Yeah.
So we do negative 64. It spits out our negative answer, which is right here. But again, be careful. If you're doing square roots, your calculator's dumb and a lot of times gives you the wrong sign. So like if I do square root of negative 64, domain error, quit out.
I've only ever noticed
So second square root.
Hey, Preston, thank you for doing this. I have no idea how to actually.
I can't do this. This is impossible. The square root of a negative, it won't work no matter what, because it can't happen. Physically cannot happen. Mathematically, it's broken.
Some calculators will calculate it, but they'll give you the wrong answer.
So that's where the imaginary numbers, which aren't imaginary, they exist, but that's where those come into play. You'll get there in high school math too. You don't need to understand it now, just understand it can't happen. So cube roots of negatives can't happen. That is your little calculator drop knowledge for right now. And this is your button for fraction decimal. So if you're trying to convert that, so if I do 8/9 and I get the decimal answer, I can hit that and get the fraction answer.
We have these calculators.
I know. I ordered these after you guys left. I realized that they were better. So sorry I gave you the answer here, but that was -4.
So you helped us get it. We followed along.
Okay.
Calculators on the test.
Only if
Econs,
Dom,
okay.
do you have a question or?
I have a question.
Dom actually has a question.
Okay.
Okay, so on my calculator, when I do the 3-second little button, it doesn't. My 3 just stays there. It doesn't.
Yeah,
Or
that's
I
supposed to be.
No,
This is the good thing
it's
about
supposed to get
coaching.
smaller.
Do the
And
second,
Andrew's a good
and
calculator.
then that. Oh no, you're supposed to put in 3.
You put in the 3 first.
Then second.
The
Then
X. Are you using this one or this one? This. So it's that green, the X one.
I think it doesn't have to go.
I just said
I don't think it actually matters. Yours is just making it look different. So you're fine. Keep going.
Okay.
So Dom's issue was just his calculator made it look different. It's still doing it the same. It's still he's in classic instead of math. He's in classic instead of math print. That's why. So
Okay,
continue.
so
Aaron.
for these ones, it's just like the same as the last ones. With fractions, you just put it all of it under the radical to the third, and then you find out what your answer would be.
2/7.
And as you can see, they get big really fast because 7's already at 300. When you get to the 4th, that's like 1,000. Got it.
The next, 110.
Hey, my advice, everyone hit mode on your calculator. My advice is keep it in math print unless something weird starts to happen. Math print is kind of like the calculator representing things easier for you to see.
Oh, I'm
Wait,
not
are you sure it's 110?
I was in BE.
It would be 1/10 because
Bottom end.
with tens you can always tell what it is
Right.
because you just add a 0, and with 1 it just always stays the same no matter what you do.
I did all the tests over 1,000.
So now you have an aquarium and you're gonna find the cube root of it again, but it's gonna be like what we did last time with square roots, where you have to put it into decimal form because it wasn't a perfect square, and you're gonna have to round. So it would just be the same. So you take 1,256, you put it under the radical cube, and you get the answer.
10.8.
story. My fish killed my sisters again.
Sorry.
Wait, that keeps happening?
My fish keeps killing my sisters.
Okay, so let's try the goddess.
Sally.
Give people a couple minutes to worry. Calm down. There you go.
Wait till everyone.
You're on. So you have it selected. You move over. Did you need it?
I
So you're on.
I don't want to pronounce that wrong.
That's Monza.
Wow.
Of course it is.
I'm bad at picking cards.
8.8 inches.
You know, everybody had the same probability there.
I don't know about that.
Well, everybody's still in the.
I feel
Well, I
like
just kind of randomly, without looking, just grabbed it.
I think it's because he put it off to the side yesterday, and he put it off to the side.
Yeah.
While I have the presenter software open, just really quick. Sorry, go ahead and capture. So Jeremiah had an issue where he got an error that told him overflow. So if I want to reproduce that, I can type some really big number to some big power. Now this is called scientific notation. Depending on how your calculator is set up, alright, well I don't know how you got your overflow error,
Oh, I
but
pressed the 8. I pressed the square, and then I did 9.
yeah, so however you did it, you got a value way too big to be shown on your calculator. The next chapter we're going into is over scientific notation. All I want to talk about right now is if your calculator puts a number that looks like this times 10 to a power, that's called scientific notation. And that means your number's too big for the calculator to represent. You shouldn't have that happening yet. But if you do, come see me. We'll talk about what you were doing that made it happen. But you shouldn't be seeing this yet. If you do, you've kind of taken something that's too big of a power. But when working with powers, we get really big numbers really fast. So that's when we start to use scientific notation. That's all I want to say about that is that shows scientific notation.
How come my class feels longer?
Oh, wonderful.
What?
The best
I'm
note.
Oh yeah, the 3 is open if you want to transition. To the next page that we had. We have just a couple minutes left. We will start our 23. So flip to your next page, please.
Is everyone on this one? Before we go.
Yeah. It was just flipping.
Yeah, I know. Okay, so in this one, you're going to be adding numbers with exponents on them. So the way this one works is you go through and you for this. So if you have 5 to the second times 5 to the 8, you'll get. So this is what it will look like. So you'll have 2 plus 8, and you get 5 to the 10. And that's because it's the same number, so it can be added.
There's an explanation in the top in the intro.
It's good.
He's explaining it as well. Can you simmer down?
But it can I'll go straight to these. So for this one, this is all just x. You just add the exponents, so it'd be 3, 5, and 10, and you'd get 18 for x to however it's taken to. And so for this one's different. So since you have 2 different numbers, you have to multiply them together, but the exponents don't do anything yet. So you do 2 times 5 here, and you get 10. Yeah.
What does 5 squared mean? We talked about this earlier, why we use squared. Colin?
5 times itself.
5 times 5. What does 5 to the 8th mean? Sean?
5 times 8 times. Or 5 times.
5 times.
5 times 5.
Okay, so we have right here 5 times 5 times 5 times 5 times 5 times 5 times 5 all the way to 10. Because I have 2 there and 8 there. So why we add the powers
So it's easier, so you don't have to keep counting.
is because I have 2 5s here, 8 5s there, a total of 10 5s. What we're doing here is 2 times m times m times m times m times m. I don't know if I hit 10 there, but we're going to hope I did. Times 5 times m times m. So if you wanted to write this out, this is actually 2 times m, 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 m,
So on.
m, m. Can't just say so on. 1, 2, 3, 4, 5, 6, 7, 8, 9, m times 5 times m times m. That's what we actually are saying here. So that's why we actually just say, okay, I've got 10 and 2, I've really got 12, and these values can multiply by each other, so that's how I get 10.
I got the answer to A, and it's a really big
So I mean, all numbers technically can multiply together, but like
They can't always be combined.
yeah. So like if you're just trying to like simplify a problem, which is what you're really doing right here, like the m's what's the power is on, not the 2, because the 2 is next to the m. It's not how many. It's not 2 to the 10th. It's m to the 10th. So it doesn't matter how many 2's there are or 5's because that's the m. You're just multiplying those together, and that's the total number of m's. But these are how many times you're gonna have to multiply them together.
So like, Moon, the 2 is multiplied with the m's there. The 5 is multiplied. They can multiply, but they can't be combined.
Okay.
Because I can't push it together. The 2 and the 5 can be multiplied and can be combined into one other number. So that's what I mean by can be multiplied. They can be combined. So I probably misspoke there a little bit. Question or answer?
Question. How would you multiply if the m had been like some other number? If it hadn't been the same number?
What do you mean? So like if it was like 2n, is that what you mean?
Yeah.
So like, if it was 2n,
Do I not have those examples?
I don't know.
She's asking. Aha! We get to those examples. So if you want to push that question, we get to those examples.
I got a syntax error.
Up to you, but I'm going to capture it for you. Then you can talk about it if you want, or you can say hang on till the back.
I can talk about it really quick. But like, I won't go deep into it. But like, if it was 2n and 2m, you just separate it so it'd be like n to the 10th and m to the 2nd. It's kind of like they're different. Since they're not numbers, you can't put them together. But since they're letters, they have to be
But
separated.
if they were 2 different numbers.
If they were 2 different numbers, you could put them together and multiply them together.
How?
The powers would just go together.
Like adding them?
So, can you hang on to the question until we do a little bit more practice with the basic skills and then get to the more advanced skills?
Yeah.
Okay, because we get to that on the back, but you need to understand the basic skills first. You're asking questions up here with an understanding down here. Okay? So it's hard because you have a gap between your learning and your questioning. We got 1 minute, so you probably just want to wrap these ideas
Okay.
for the current time.
Let's do this guy really quick. It's really fast. So, does anyone know what it is?
Is it 11?
Yeah. So, it's just like up top, but it's a lot simpler because you don't have to go through all the steps. It's really just multiplying and adding. So you just add these and then you multiply these. But if it was division, you have to subtract the exponents.
and we'll get there next
A
week.
little 11 on
You
top.
don't need to
11.
do
Yeah,
20.3, 20.4, and by next week I meant tomorrow. But you don't need to do 20.3, 20.4 yet. Work on 20.12, and we'll get to 3.4 tomorrow. Thank you guys. Have a wonderful day. Knock the test out of the park.